Hey everyone, welcome back to my third YOLO v3 object detection tutorial. Now, in this part, I'll talk about how to prepare YOLO v3 custom training data. For example, I will show you where you can download your own data, which you can use to train your custom object without labeling by your own. So YOLO v3 is one of the most popular real-time object detectors in computer vision. If you heard something more popular, I would like to hear it. In my previous tutorial, I showed you how to simply use YOLO v3 object detector with TensorFlow 2 application and how to train Mnist custom object detection. At the end of the tutorial, I promised that I will show you how to train custom object detection. It was a challenging task, but I found a way to do that. However, before training a custom object detector, we must know where we might get a custom dataset or how we should label it. So in this tutorial, I will show you where you could get labeled dataset, how to prepare it for training, and finally, how to train it. In this step-by-step tutorial, I will start with a simple case of how to train 7-class object detector. Well, we could use this method to get a dataset for every detector you might use, almost every. Therefore, I will build a vehicle registration plate, traffic sign, traffic light, car, bus, truck, and person object detector. This is my 7 classes. So first, as with any deep learning task, the first most important task is to prepare the training dataset. The dataset is the fuel that runs any deep learning model. Same as in my past tutorial, I will use an image from this open image v6 dataset. It's a publicly available online. It's a very big dataset with more than 600 different categories of an object. The dataset contains the bounding box, segmentation, or relationship annotations for these objects. As a whole, the dataset is more than 600 gigabytes of size, but we will download the images and classes only needed for our custom detector. So we have a link to this large dataset, but it's not explained how we should download images and label we need. Should you download them one by one? No, there is an amazing OID v4 toolkit from GitHub with a full explanation of how to use it. And actually, this is on my GitHub, as you can see, but I forked it and added 2 more classes. This is from my past tutorial, and you shouldn't use them now because I'll update them, and this will be easier for use in this kind of tutorial series. So this toolkit really makes our life easier when we want to train a custom object detection model with a popular objects and when we don't know where to get labeled images. This toolkit allows downloading images from OID v6 seamlessly. This installation is easy and clear explained in the README file. The toolkit is loaded with a variety of options. For example, the OID v4 toolkit allows us to download almost any particular class of interest from the given database. Well, actually, you can explore the database in this link. You just click on Explore Database, and you are here, and you can check if the object you need exists on this current database. So the toolkit can be downloaded from this link, GitHub. I'll of course post this on my descriptions or on my text version tutorial, and you will be able to find it. Or you can, if you're on GitHub, you can clone this. And of course, next step, when you downloaded it, you should install requirements because there is one file about them. But if you already installed requirements from my tutorial, I actually added a missing library so you would install everything at once. So I will quickly show you how to use this. I will copy the link of it and I'll open I already downloaded it, so I'll rename it for a moment, and I will open a terminal and I'll write that git clone and the following link. It will clone this toolkit. As you can see, it's already cloned. What I need to do, so what I need to open it, cd void v4 toolkit, and I already have prepared line for downloading classes. And actually I will try to download test files. Of course, I'll add everything on my text version tutorial. So I first click this, and at first start you'll be asked to download class description boxable CSV file. As you can see, this file contains the names of all 600 classes with the corresponding label name, and of course then later you'll be asked to download test annotations box CSV file and train annotations box CSV file. Sorry, I should write yes. These CSV files contains one boxing coordinates for one image, and it also has this box label name and current images ID from a validation set of OID v6. So these files will be in this file. I can open it in this OID folder and in CSV folder. As you can see, it's already asking me for CSV to download. Okay, I'll try. I press yes. And if you don't know which classes you would like to download, first you should check if the database has an appropriate image class we need. So usually I go to this page. I already clicked on explore, and in search tab I'll try to find my needed class. For my example, I will search for a bus, car, person, and so on. So I, for example, can write a person. Yeah, person exists, and as you can see, it's already labeled a dataset for person, and it doesn't matter. I can write a license plate, no, it can find for some reason. Okay, car. Oh, it's vehicle registration plate, so I can write a vehicle registration plate, for example, and it got a lot of images with vehicle registration plate. So to download all of my data, I can simply use OID v4 toolkit. So as I showed you already, I opened this toolkit and I wrote, where's this line? It's not here, but anyway, I'll post this in the text version tutorial, what line I used to download, train and test dataset. So actually, with these commands for this tutorial, I will be downloading 2000 training images for each class, and I'll place them in the train folder. So where is my folder? So for example, it will be this one, dataset. Right now it's downloading test. So when it finishes, here will be not only test but also in train. So actually I already have downloaded this, so I can open another toolkit which I commented already, and if I'll press OID, here is dataset, and as you can see, here is test and train dataset. If I open it, there's a lot of classes, so I'll close this. We don't need this anymore. You'll test it by yourself. And as you can see, the structure should be the same for you, because for training, for validation, we must use test dataset, and for training, we use train. And I recommend to use as much images as possible. That's why I use 2000 images. And file structure should be the same. So I'll write in my text version tutorial how our file structure should look, but of course it doesn't matter for you. If you are experienced programmer, you can handle it, but for beginners I recommend to stick to it. Next, when we have finished downloading our dataset, we need to convert label files to XML. So for example, if I'll open one of these files, at the beginning there won't be any XML files. So we go to labels, and as you can see, there is a txt file, and here in this txt file you might see class and coordinates of points in type of name of the class, left, top, right and bottom coordinates, where each coordinate is denormalized. So the 4 different values correspond to the actual number of pixels of the related image. So we need to convert the text annotations format to XML. You may ask why we should convert it to XML. XML format is quite popular and often used in other object detection algorithms. So I wrote a script to do this conversation, and I'll close this and we go to my main folder. I'll delete this one and I'll remove this. And if you'll go to my tools, I wrote a script to do this conversation. So if you follow this tutorial and have the same file structure as I mentioned, in the tools folder is OID to Pascal was XML file. So you should open it, or you can run this from the main repository. You should simply run this script, and after it finished conversion, you should find XML files created. So I'll run this from my main folder, and I'll write that Python and I'll tools folder, and I'll run a script OID to Pascal was XML.py. And as you can see, I have 2000 images, and it right now converts all these TXT files to XML files. And it might took a while, but not so long to convert all these classes actually. So because I already have converted all these classes, I can close it and we can go to another step. So close it. So right now we have these all XML files. We should now convert this to a YOLO v3 file structure. So I can open the script and I'll open the dataset, how this structure looks like. For example, open train bus, and I'll open one of my XML files. Open with. Okay, I opened this on my browser. As you can see, this is the path to my JPEG file. This is file name, and here is the width and height of the file. It's RGB, depth of 3, it's bus, and so on. And bounding box is this one. It said that it's almost full size of the image, the bounding box. So now I'll run this script, and keep in mind that you should change these lines according to yours. And for example, this is the direction of data. Where is my folders, train and test folders. Next is dataset names path. So I'll create new files in model data folder from here, not from here, in here, model data, and it will create our dataset names, dataset train, and dataset test files. I already have these created, but actually I can create them again, so you'll see how it looks like. And again, I'll run this from this repository, and I'll write Python tools and XML to YOLO v3. Great, it does this task quite quickly, and as you can see, here is all my classes. So right now you don't need to write all these classes in file manually. It will generate these files for you. And if we would open one of these files, for example, if I'll open dataset train, as you can see, there is one row for one image. Row format is as image file path, box 1, box 2, and so on. Box format is that at first it goes x minimum, I minimum, x maximum, and y maximum, and then goes class ID, and then goes another bounding box and third bounding box, and it doesn't matter how many bounding boxes there is. So right now, when we have prepared all these files, we go to my main folder, and Last step to do is to configure the configurations file, which is here, configurations file. I already prepared it, but I commented a lines which you need to comment and where you need to what to write. So actually we need to change only 4 lines. So this is train classes, train annotation path, test annotation path files, and I recommend to write a train transfer as true and train data augmentation as true, and actually I'll explain this for you later why. And now there's a train epochs of 100, and this number you choose by yourself how long you can train and how large data set you have. So for example, for this data set of almost 40,000 images, I'll train it for 100 steps, but actually I would need it to train for about 200 steps to get a better results. So now we have everything prepared for training. So simply how to start training, I open terminal, write python and train.py and run this. Actually I had checkpoints of TensorFlow and now it's fucked up. I don't know how to show you an examples, and sorry for my bad words. And actually I don't know how to show right now how a TensorFlow, and actually it doesn't matter. Now I train it, but because I have already trained a model, I can write it a little bit differently. So I'll exit this. One more thing I would like to explain from this code. What's the difference if we use transfer or we train from zero? So transfer learning is a technique to reuse the already pre-trained model on a new problem. It's currently very popular in deep learning because it can train deep neural networks with comparatively little data and in a much shorter time. This is very useful since most real-world problems typically do not have millions of labeled data points to train such complex models. In transfer learning, the knowledge of an already trained machine learning model is applied to a different but related problem. For example, if you trained a simple classifier to predict whether an image contains a car, you could use the knowledge that the model gained during its training to recognize other objects like a truck. With transfer learning, we basically try to exploit what has been learned in one task to improve generalization in another. We transfer the weights that a network has learned at task A to a new task B. In general, idea to use the knowledge a model has learned from tasks with a lot of available labeled training data in a new task that doesn't have much data. Instead of starting the learning process from scratch, we start with pattern learned from solving a related task. So the transfer learning has become quite popular in combination with neural networks that require huge amounts of data and computational power. Before I showed you a config.py file and you might saw the train transfer line. This is used to use transfer learning or not. This is how transfer learning looks in my code. First, we create a model with original weights here, and there's darknet weights, and then we create a custom model, and here our custom model with custom detected classes, and here we try to copy all the weights from original model to our new custom model. These exceptions are added to skip layers which are on different size of output. So this is the simplest way how to avoid errors. So to make a better understanding or why we use transfer learning, I trained two models with the same dataset classes. So right now let's look at the results with transfer learning and without transfer learning. So first, here are the results from TensorBoard without transfer learning. To evaluate our model performance, we will look at total validation loss. This is why we need testing data while training. As you can see from this chart, we achieved the best results with around 42nd step with an evaluation value of around 8. To get this model, it took almost 1 to 1 hours of training to get at this step. Next, here are results from the TensorBoard with transfer learning. As you can see, the graph looks different. So while using transfer learning, we achieved the best results within the 7th step of validation with an evaluation value of 6.6. And this took only 3 hours. As you can see, after this point, the validation curve began to rise. This means that we started overfitting and it's not worth to train it. The only way to make it better is by getting more training data, use more augmentation techniques and other techniques. So from this tutorial, we'll learn where and how to download custom training data, how to prepare data from training, and how to choose which model is best. In the next part, I will show you how to label your own data and how to train custom object detection on your own labeled data. So thank you all for watching. I hope this tutorial was useful for you and see you in our next part. Goodbye.